This is Stata Workshop 2024, Day 4, Section 1. Okay, welcome to the Day 4 of 2024 Stata Workshop. This is the last day, and I'm excited to see you again. And um, today's session focuses on structural equation modeling, which is the last part of our intermediate module. And let's go back to the preview that I demonstrated yesterday around the last part of day 3. So I will restart the log. and I'll open auto.dda, which is data file. And I will also open the diagram of auto SEM. So this is very simple multiple path model. And um, when we conducted simple regression on day 2, we tried to regress between price and mile per gallon, mile per gallon being a dependent variable and the price being independent variable. And we have seen some significant relationship between price and mile, excuse me, price and mile per gallon. However, um, we had some doubt whether higher price directly means the poorer mile per gallon. So by using SEM, we can draw this kind of multiple path model that we cannot do by using regression technique or correlation. So basically, this is the three regressions combined together. And if we run, if we execute this, the SEM, let's make it standardized. And also, I'd like to see foreign cars case and domestic cars case. And please watch the main window here. It will take a little bit of time because SCM calculation is a little bit heavy. Okay, since this model is relatively simple, it took just a matter of seconds. However, if you run the model with multiple variables and a complex diagram, it may take hours or one night or even several days. So please be careful when you decided to apply the SEM to your research purpose. And yesterday, around the end of the session, we have seen the price and the weight of the mile per gallon. They had very strong positive and negative relationship. However, the direct effect from price to mile per gallon had much smaller effect. So, the higher the price, um, this means for in case of domestic car, in case of domestic car, the higher the price, higher the mile per gallon. However, in case of foreign car, the relationship was different. Price higher the price, lower the mile per gallon. However, as compared with the relationship um, through price, weight, and mile per gallon, this coefficient is much smaller, either in the case of foreign car or domestic car. However, yesterday we haven't checked the significance of these coefficients. So let's check the significance. To check the significance, we go to the estimation, testing, and just let's see. No, goodness of fit. Um, Okay, let me check. No, this is not. Um, okay, direct and indirect effects report standardized effects. And click OK, and let's watch the main window. Here we have direct effect, which is direct connection from price to weight, weight to mile per gallon, and the price to mile per gallon. And if you see here, we have Z value, which is for the testing of the significance. To be specific, this is the estimated value divided by standard error. But you don't have to care about it. What we will take a look at is this significance level of Z value. And um, from weight, let's take a look at the from weight, domestic weight to mile per gallon, or um, let me see, let's make it more straightforward. I will forget about the foreign buses. Um, okay, so here the relationship is straightforward. Uh, I mixed the foreign cars and domestic cars together in this model. So we see um, the direct effect from weight to per gallon, from weight to mile per gallon. The coefficient was minus 0.78, which was quite strong. And what is the significance of this number? Is this number statistically significant and reliable or not? If you look at the p-value, 0.000, extremely strong. So we can very confidently believe this number is credible. At the same time, the relationship from price to weight, direct effect of price to weight was positive dot 0.54. And the p-value is also 0.000. So this is very, very credible, significant number. However, if you look at the price to mile per gallon, this direct effect, the p-value is 0.557, which is much greater than 0.05, which is the commonly used criteria for significance. So, although the starter calculated this direct effect, however, this number is not worth believing. 0.557 significance level is very poor. And the indirect effect, um, price, weight to mile per gallon, price, indirect effect to mile per gallon through weight is credible. And the total effect price weight to mile per gallon, price weight to mile per gallon is credible. And from price to weight, from price to weight, the number is credible. So by conducting this estimation, goodness, testing and the direct indirect effect, we can double check whether these coefficients are credible or not. Okay, so this is the introduction, and now we get into the contents of SEM. SEM is much more flexible and powerful. However, it requires much more computational power. The examples that we are going to use within this exercise will be small set of data. So the computational time will be relatively small, relatively short. However, if you use the big data, it will take a lot of time. And the SEM around 10 or 20 years ago, the SEM used to be a high-tech analysis method, and the only it was used only you know the re the researchers who are very strong in terms of statistical knowledge. However, these days the it became a kind of standard or very commonly used technique. So, um, even in your research paper, wherever it is appropriate and desirable, you may want to consider the usage of SEM. And it enables combining multiple complex analysis into one model. So, um, as we have seen, um, we combined price, mile per gallon, and weight, three variables together in one model, which was not possible in case of regression or correlation. And in this manual, we learn how to build SEM models on Stata and run optimization calculation. And we will learn the minimum knowledge of the way to interpret the output. However, you will need to learn much more if you use it in your research paper or thesis beyond the scope of this manual. So, SEM is very powerful. However, the theoretical foundation is very, very complex. So, please be aware of that. So, let's start with the single factor measurement model. ACM1FM.dta, which is the data file, it contains 500 observations and four variables, x1 to x5. We do not know the meaning, but these x1 to x4 include the some integer number, and we will build the picture like this. From now, you will draw the picture like this. So, together with you and me, the purpose is for first purpose is to draw this picture. Okay, to draw this picture, and to start with, simply you open SEM underscore 1FMM.dda. You open Stata and you open File and, oops, you open File and you look for SEM1FMM.dta and simply open the file. Don't forget that you continue using the log file. I will append the record. Okay. And of course, you can open the data editor to check the content of the data. It includes ID number and X1, X2, X3, and X4. Let's put the variable name to this one. Um, Probably it's not necessary, so let's forget about it. Okay, so simply we have X1, X2, X3, and X4, and each of them have some number here. So let me check if you finished importing this data set. The only thing you're going to do is open SEM underscore 1fm.dta and to just to make sure you open and continue logging. Okay, let's go ahead. If you type describe or um, if you conduct the summary, statistics summary, summary descriptive statistics, and summary statistics, then you will see the outline of this data set. Okay. Or you can, alternatively, you can use describe, which will also give you the outline of this data set. But anyway, let's go ahead with stata diagram. Before running the SEM model, you need to draw the diagram. So let's start drawing the diagram. To do that, you go to statistics and look for SEM and module building and estimation. And you will see this, the workplace. And um, if you click this one, then you will see the adjust canvas size. So um, please go ahead, statistics, SEM, model building and estimation, and click on this one and come up with adjust canvas size. Statistics, SEM, model building and estimation. And you click on this one.
Professor, next one.
Next one, Professor.
Yes, click next. Next one.
This one, all right. Sorry. So, if you draw very complex, model, then you will need the big canvas size. So you can change the canvas size. This 6 by 4 inch is a standard default size. However, you can change the canvas size like the very big canvas size. If you have lots of variables and lots of latent variable, then you may need very big field. But let's conform with 6 by 4 for our example. Okay, so if you finish doing this, let's just save it to whatever place. SM-1 is okay. So I saved it, and from now on, I will draw the picture on this canvas. So if you finished creating this canvas, please respond to the poll. Okay, so just a few of you are working on that, so I will wait a little bit more time. So thank you for correction. So this one and the canvas size.
Sorry, Professor. I have no this button that we should input. Adjust canvas size. It should be, yes?
Um, you
This
you
I
do
only have left one, but right one I have no. I don't know why.
um
Or I should
let's
do something before.
let's see. I haven't encountered such kind of situation. However, um probably you can close the canvas and try to restart from the beginning,
Oh, okay.
statistics, SEM, and the
Mhm.
model building.
Okay, I will try. Thank you.
Without having this canvas, we cannot go ahead. So please make sure that you develop this blank canvas.
Okay, thank you.
Okay, so far, out of 36 participants, the 29 people finished drawing the canvas. Okay, another person came in. So just to make sure to proceed, let's start from the beginning. You open SEM1FMM.dta. You open it on the Stata, and you go to Statistics, SEM, Model Building. Then you will see this canvas. That's it. Okay. Um, okay. Many of you finished coming up with the blank canvas. So let's draw the picture. Here's how. You have several menus, several tools here. If you see the canvas, here we have several icons or tools. And this time we're going to use this one, measurement component option. In addition to that, we have regression component builder, or simply creating observed variables or latent variables. And this is the regression path, and this is the covariance path. And this is to create, this is to create the one observed variable instead of multiple variables. And this is this has nothing to do with current practice. This has something to do with generalized SEM model. So let's use this one, the measurement component. You click on that, then if you click somewhere around here, then this the dialog window will come up. Okay, so you click measurement, and click somewhere around here on the canvas, and you see this dialog. Okay. Up to here, please do so. Okay. Then we decide the name of the latent variable. Latent variable is hidden indirect variable that you create from observed variable. In this case, x1, x2, x3, and x4. So the latent variable is the synthesized variable that you create from the observed four observed variables, which is generated by Stata, and it doesn't exist right now. And the name of the latent variable has nothing to do with your computational result. So you can name whatever, you can put whatever name, but the name of the latent variable should start from uppercase alphabet. In day one, I advise you for observed variable, you should start from lowercase alphabetical letter. However, here, for the latent variable, you should use the variable name which start from uppercase alphabet. And since the measurement variables are x1 to x4, I chose the uppercase X. So I will choose X here. And here we select variables. Simply we can choose x1, x2, x3, and x4. And this is just a cosmetic part. However, if measurement direction is left, then the let me demonstrate. If you leave it left, then the picture will look like this. The observed variable comes to the left side of latent variable x, which does not look good. So I will undo, and once more I will do it again. I will name the latent variable as x, and I will choose x1, x2, x3, and x4. And after that, I'd like to place the observed variable under the latent variable x. And click OK. So here we see the picture. Probably the canvas size was a little bit bigger. Maybe 4x4 may be good enough. But you need to move the picture to the appropriate place. So you don't have to do this. The bigger canvas size does not affect any computational results. So this is just a cosmetic issue. But if you put the diagram to show on your research paper or thesis, then you may want to make the canvas as appropriate size so that it will show the nicely on your paper. And let's save it, or if you have not done so, save as. Let's save the file for later use or in case of the data loss. So now we successfully developed the latent X explained by 4 observed variables. And the epsilon 1 to epsilon 4, these are automatically prepared to calculate the error term, because all variables will have the error or standard error, which cannot be used to synthesize the data into the latent variable of X. So you don't have to worry about this. It will automatically generate it. Okay, so if you if you have completed drawing the picture, please respond to the poll. Okay, good job. And this model, we defined that x1 to x4 can be explained by one single latent variable, which is our hypothesis. And so this is roughly equivalent to confirmatory factor analysis. There are many other, the more established CFA techniques. However, this roughly emulate the CFA. As the next step, simply we execute the estimation. So it's just simple. You click on the execute button here, and let's do nothing and just click OK. Then the calculation will be done and some numbers will appear. Okay, so you do that. Okay, then you will see something like this. And let me explain the meaning of the numbers. 90 under the latent variable x means the variance of x. And these are coefficient between x and x1, x2, x3, x4 respectively. And these numbers represent a constant coefficients, just like the intersect or the constant the variable that you see in the multiple regression. And these numbers next to the epsilon is the variances of error terms. However, these numbers are not standardized, and we have no idea whether these are good number or not. So let's standardize the number.
Professor, the coefficients are okay, but what is the constant coefficients?
Constant coefficients. These are, think about the case of multiple regression. Then, or even simple regression. You see the constant and the coefficient, right?
Yes.
So this constant coefficient represent the constant number, the for x1 to x4. Constant and the coefficient. So this is analogous with multiple regression.
Okay.
Okay.
Yeah.
Constant and the coefficient which represent the slope. However, technically, there are some complicated matter in the case of SEM that I will explain later. And if you click, for example, if you click X4 box, then you will see more detailed information, just in case you need to rigorously check the nature of each calculation. And output, just a moment. So SEM command, then you will see the result SEM x to x1, x to x2. This is the command line generated from the diagram that you have just developed. And endogenous variables x1 to x4 and the latent variable x. And the 4 times of iterational computation has been done before convergence. And the number of observations 500. And ML stands for maximum likelihood, which is the method of optimization. And here we have the coefficient of the first variable. Due to the model restriction, the first variable always it is set to 1 due to the technical reasons. So this constraint number, this will be always 1 for the first coefficient, x1. For x1, the coefficient will be set to 1 always. However, for x2 to x4, there will be the calculated coefficient number. And these coefficients are just the same with what you see on the diagram. Here, x2 coefficient, and you don't have to worry too much about this part, but just to explain the meaning, this is standard error or the residual that has not been appropriately used to generate x, latent variable x. And here we have the confidence level. In this case, all indicator shows 0.000, so the fit was very good in generally speaking. And here we have confidence interval. The interpretation is just the same with the case of regression. And finally, this is the badness of fit test. If p value is greater than 0.005, then the model is generally acceptable. And in this case, the number of 0.48 much bigger than 0.05. So overall, this model was judged to be appropriate and acceptable. And here, since the number is not standardized, let's make it standardized. To do so, please come up with this diagram and click execute once more to come up with this diagram, the dialog, and click on reporting. Then put the check mark on display standardized coefficient and the variables and click OK. Then the recalculation will be done and the number will come up like this. Then it is much more straightforward. Since the number was standardized, it's much easier to understand. to synthesize these four variables into the latent variable x, the contribution or the strengths of relationship among the between x1 to large x, x2 to large x, um, each one has different contribution or different strengths or influence. X4 had the strongest influence to generate the latent variable x. And the meaning, you don't have to fully understand. However, this is just like the multiple regression. If you understand how multiple regression work, it's very straightforward. Here we have beta. Beta is coefficient, or in case of the linear regression, it's slope. And constant is intercept, or the crossing point with between slope and y-axis. So it's intercept. And since there are many noises, we have the errors or residual terms. In short, this simple SEM tries to find the best X which can explain X1 to X4 with good alpha and beta. And finally, this is very important step. Every time you run the SEM estimate, after estimation, always you need to conduct goodness of fit check. And here's how. You start from statistics and go to SEM again, and you go, the menu may be different, but the goodness of fit and the overall goodness of fit. Let me try that out. Statistics, SEM. Yeah, we have no problem. Goodness of fit and the overall goodness of fit. Then GOF is selected already, and you choose all of the above from the drop-down menu and click OK. Then the goodness of fit indicator will appear. So please do this on your side. Again, it's simple. Go to statistics, SEM, and the goodness of fit, overall goodness of fit, and then select all of the above and click OK. Somebody having problem? Everything okay?
Okay, Professor.
Okay. So far, 26 people finished doing this out of 38. 27. I'll wait for another 20 seconds. Okay, then we need to interpret this goodness of fit indicators to conclude whether our practice was good or not, our model was good or not. And there are two most essential indicators. RMSEA, root mean squared error if approximation. You don't have to remember, but we normally call it the RMSEA. And the RMSEA, smaller the better. 0.00, perfect. Generally, the researcher says if the RMSEA is smaller than 0.08, then the fit is good. And another important indicator is CFI, comparative fit index. And reversely, CFI, bigger the better, closer to 1 the better. In this case, 1.000, which is perfect. And the statisticians argue that if the CFI is equal or greater than 0.9, the fit is good. Of course, there are other important indicators like Akaike's information criterion and the Bayesian information criterion. However, these numbers, they do not have definitive criteria to judge whether the model is good or bad. It all depends on the model type and the data, nature of the data. So I will not discuss in more depth how to interpret AIC and BIC. However, whenever it is necessary, please check on that. Questions? Okay. Then, let's check the equation level goodness of fit, which is one more further step. And you simply type in the command line estat eqgof. Of course, we can do that from the menu window. However, it's easier to type in. So, oops. Um, so type estat eqgof and you'll find the result here. Okay, currently 25 people finished out of 40 people. Okay, so you can continue working on that, and I will explain the meaning. The degree of fitness or degree of contribution and R squared. Um, you can read R squared the similar way as you examine regression result. So R squared, as we have seen in the diagram, I have one chat. R square command R is unrecognized. Janibek, could you explain what happened to your screen? Is it okay? Okay, good. Okay, okay, I'll go ahead.
I got the
So,
same displaying, yeah.
okay. So as you see in this, not this one, but as you see in my diagram, X4 contribution is 0.99, the biggest, and the second biggest is X3, and the third X2, and the fourth X1. Similar to this finding, equation level goodness of fit indicate X4R squared was biggest, and the second biggest was X3, and very close, but the X2 the third, and the X1 the last. So if you, in case you see very poor R squared here, like a 0.05 or 0.09, you may want to consider excluding, for example, X1. If you consider X1 is too poor, then you can click on X1. Before doing that, you need to click on this arrow icon, and you choose X1, and then delete. Then I can exclude X1 from the estimation and rerun SEM without using X1. So the usage of SEM is a kind of a trial and error. It is not always the case that you build a certain model and it perfectly fits very good. However, sometimes, very often you need to tweak the model so that the goodness of fit becomes very good. Okay. So please remember that to run the good SEM, you need, very often you need to conduct trial and error. And here we have the data memory, the save, just to keep our work so far safe. Let's save the data on memory. We have done it yesterday. You go to statistics, post estimation, and then under manage estimation result, you select save current estimation to data and click launch, and put any file name that you like. So go to statistics and post estimation. I'm doing that on my screen. Post estimation, manage estimation result, save estimate to disk, launch. Okay, I will name it SMM1. Then you are done. Okay. So please save the data to the memory data to the disk. Okay, good. Then we have done it. So I will skip it. And the next, we will do the two-factor measurement model. So now please open, before that, let's save the one-factor model that we have drawn for your, so you can choose file and save, or if you want to save the file with under different name, please choose save as. And after saving, please close this diagram and and the newly open SEM2FM.dta. File open SEM2FMM.dta. Open. It's simple, but let me check your progress. Okay, by the way, this data set is it has 216 the responses or samples, and it asked 10 questions. A1 to A5 is affective arousal, affective or the emotional thing. And C1 to C5 is a question related to the cognitive arousal or logical inspiration, logical the concept. So A1 to A5 and C1 to C5, they are trying to measure different construct, different concept. So we want to generate two different latent variables like this from A1 to A5. Based on A1 to A5, we generate affective latent variable. And by using C1 to C5, we generate cognitive latent variable. Then on top of that, we want to measure the covariance or strengths of relationship between affective latent variable and the cognitive latent variable. And I recommend that you set canvas size 8 by 4 and draw this diagram. Okay, so I will start drawing this diagram by myself, A1 to A5, C1 to C5, and name it affective starting from uppercase A, starting from uppercase C to determine these are latent variable, affective and cognitive. 8 by 4, the 8 by 4, the canvas. Go to statistics. Assuming that you already imported SEM to fm.dta, I go to statistics, SEM, model building and estimation, and I will set the size 8 by 4 and click OK and fit the canvas 8 by 4. Okay, now I'm ready to build two measurement component. I will go to measurement component, and around here, I will create affective latent variable, and the affective latent variable, I will place A1 to A5 and downside. Okay, so like this, and I will create another latent variable around here. If you make the diagram a little bit messy, it is okay. You don't have to worry about the nice looking diagram. Messy diagram is okay. So next, cognitive latent variable, starting from uppercase C, and the C1, C2, C3, C4, C5, and downside this direction and click OK. Oh, it's a little bit messy, so I will move it by using arrow key. It's not fully aligned. If you do care about the nice looking the diagram, you can go to edit, you can go to object and align. Then you can align the object by using that, but it is just the uh, aesthetic or the cosmetic issue. So we don't care right now. So let's click the arrow and click somewhere around here. Then next, click covariance, two-headed arrow, and connect affective and cognitive. Okay. If you don't like it, then you can do that again. You can click edit and undo and do that again. It's nicer, right? Okay, so I constructed affective latent variable and cognitive latent variable under which A1, A5, and C1, C5 is connected, and affective and cognitive are linked by way of covariance. So I will retake the poll. Okay, it's going very well. So far, 28 people completed. If you want to check the contents of the data, you can always go to a data editor. Here we have observation. If you cannot successfully develop this diagram, then you may want to go to, if you may want to go to this, the lifesaver files. Lifesaver files, under this folder, you can find the GSEM 2 FMM result SCSMM. This one include the completed diagram that you are now trying to develop. Okay, let's go ahead now. So similarly, we will run the estimate. First, let's try simple non-standardized estimation. You go to execute, and without doing anything, you click OK. Then the calculation will be done. However, it's already standardized because the data remember what I did so far. So here, this is non-standardized result, and the affective has the variance of 1,644, and the cognitive has 456, which doesn't they make sense to me. So you go to the estimate once again, and under reporting, you put check mark of standardized and click OK. Then you will see the standardized number. And similar to I have problem of looking at the covariance is invisible, so I will move everything. I will choose everything and click. I will hit the downward arrow on my keyboard to move down the entire picture. Then now we can see the entire picture. So, similar to the case of one-factor analysis, we can see the strengths of contribution or relationship among A1, A5 to affective, and the C1, C5 to cognitive. And on top of that, we have the covariance of 0.81 between affective latent variable and the cognitive latent variable. So here we can see the cognitive arousal and the affective arousal has very strong correlation, or here I mean covariance. So affective latent variable and the cognitive latent variable has very strong connection. That's what we found so far with this the two-factor ACM analysis. And I'm gonna save the file ACM. I will name it two FMM, whatever name you can put. Okay, so that's the two-factor SEM example. And of course, after doing this, you need to run the goodness of fit, the test. Chi-square number here was poor, so we will run the goodness of fit test. So after seeing this result, chi-square probability was 0.000, which was poor. However, we can double check the goodness of fit by going to the goodness of fit, overall goodness of fit, the goodness of fit, everything, and click OK. Then we can look at the RMSEA, smaller the better, 0.08. As we have seen, slightly greater than 0.08. Here, the RMSEA is 0.087, slightly greater than 0.08. So, generally, it is not acceptable, but it's very close. And CFI, bigger the better, closer to 1 the better, 0.977, as you see here. CFI 0.977, which indicates very good fit. So, generally speaking, this is not as good as the case of one-factor SEM. However, we can see this model is fairly good. And after 30 minutes of break, we will consider how to improve this model further. So it's 6:30 now. So I will temporarily disconnect this the Zoom meeting, and please come back just before 7 p.m. Thank you.
Thank you.
Thank you,
Thank
Professor.
you, Professor.
Thank you, Professor.
Thank you.
Professor.